many entities should participate in a relationship, then we are going to call that as a constraint, that is limiting the participation of an entity in the relationship set. What is the minimum number of entities that will going to participate in the relationship with another instances of another entity, that will going to specify the participation constraint. Single rectangle in order to specify the relationship, but if we have a double rectangle, that specifies that is having a weak entity relationship type here. Hello everybody, a warm welcome to one and all. Welcome back to the last session of chapter 2 in the unit 1 of B.Ca's third semester subject called Database Management System, in short that is Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So just before getting into our today's session, we'll just have a quick recap of our last session. As you all know that in the last session of this chapter, we had a discussion regarding what are the different types of attributes we have. Along with that, we got to know what is key attribute, and also we had a discussion regarding domain of an attribute. And also we have discussed regarding this relationship types as well as the relationship set. So in our today's session, we'll going to see about the structural constraints. So the togetherness of this degree and cardinality ratio of a relationship or a participation will going to make the structural constraint. That is also I will be discussing. Along with that, we're going to see what is weak entity type and what are the different scenarios we have in it, and at last we'll see the last topic of the unit, that is ER diagram. So in order to have this ER diagram, what are the different shapes we have, along with that how do we name that ER diagram content, everything that I will be discussing in the today's session. Let me get into the first content, that is regarding what? Constraints on binary relationship. So now we'll see what are the first topic that we have, that is all regarding constraints on binary relationship types. Already you know that we have a different kinds of relationship here. So it will going to include unary relationship, binary, ternary, n-ary. So in this mainly we are concentrating on this binary relationship types. So here we have certain constraints, that means certain restrictions or limitation that we are having here. So that the relationship types are generally have a certain constraint that limit the possible combination of an entity that may participate in the corresponding relationship set. So here we are restricting the number of combinations or combination of an entity that will going to participating in a relationship set. So how many entities should participate in a relationship, then we are going to call that as a constraint, that is limiting the participation of an entity in the relationship set. So in order to establish this, we are going to have this cardinality ratio and participation constraint. So that relationship where two entities are participating, then obviously we call that as a binary relationship. So here mainly we have several types of binary relationship constraint. In that first, that is going to be cardinality ratio, and we have a participation constraint. We'll see the first thing, that is all regarding cardinality ratio. So here, what do you mean by cardinality? That specifies the number of rows or number of records. Okay. So cardinality is the number of instance of an entity from a relation that can be associated with a relation. How many instances or how many records or tuples are participating from that entity in a relationship, then we call that as a cardinality ratio. And also it can be defined as a number of times an entity of an entity set participating in a relationship. You just imagine we have certain entity set. In that I have entity 1, entity 2 like this. So how many entities are participating in a relationship, then we call that as a cardinality ratio. So that can be what? 1-to-1 cardinality, 1-to-many cardinality, many-to-one cardinality, and many-to-many cardinality. So these are the different types of cardinalities we have. We'll see the first one, that is all regarding 1-to-1. As the name indicates, so you need to imagine here we have one entity set, here we have another one entity set. How many instances of this entity is participating in a relationship with another entity, then that will going to define the cardinality. When it comes to the one-to-one, when a single instance of an entity is associated with a single instances of another entity. So here I have a set of entities in an entity set. Here also I have a set of entities in an entity set. How many instances of this entity is participating in this entity will going to define the cardinality. If only one entity or only one instance of an entity set participating, or it will going to be associated with a single instance of another entity, then we call that as a one-to-one cardinality. And how do we mark it? That is 1:1. So here one instance is associated with another instance of an entity in the another entity set. So here each entity of the entity set participate only once in a relationship. So here you can see the example here. Here I have one entity and this rhombus specifies the relationship, and we have one more entity here. So one instance of this entity is participating in this relationship with one instance of another entity. Then we call this as a one-to-one relationship. So here you can see that here I have a entity set A and entity set B. So A1 is participating only with B1 and A2 is participating only with B2 and A3 is participating only with B3. So that means what? Only one instance of an entity is participating in only one instance of another entity, then that become one-to-one cardinality. So what I can take the example, one person can have only one passport. One person can have only one Aadhaar card number. That specifies what? One-to-one relationship. So here you can see the example. If you consider the hospital scenario, at the time surgeon department will going to be headed by only one HOD or head of the department. Then that will going to serve as one-to-one relationship. Surgeon department has or headed by only one HOD, and only one HOD is going to head the person or a particular surgeon department. This is what? One-to-one cardinality. Then what about this one-to-many? As the name indicates, only one or single instance of an entity is associated with more than one instance of another entity. So from this side I have only one entity that is going to be participate with more than one entity in the set B. Then we call that as a one-to-many relationship. So that is also called as one-to-many relationships here. In one entity set can take participate in any number of times in the relationships types, and entities in another set can take participation only once in a relationship set. Then how do we define it? One to many. Many specifies n here. You can see the representation here. Here we have a entity and that is participating in a relationship with many instances of another entity. That n specifies number of entities. This is one-to-many relationship. Then what is the example here? You can see we have a two entity set A and B. This A1 is participating more than one time with instances of entity B. So A1 is participating with B1 and also it is having a relationship with B2. That means one to many. It is participating, or the one instance of an entity is having a relationship with many instances of another entity. So you can take the example of same doctor or hospital scenario. Here surgeon department. So in a particular hospital, surgery department has multiple doctors. One department or one specialist will going to have n number of doctors. So single teacher will going to teach us many students. That is also the single student will going to study many subjects. That is also one to many. So this representation is important. One to many. Fine. Next what we have here, many to one. It is just a vice versa of that. So many instances of one entity is participating with only one instance of another entity. So that when the entities in one entity can participate only once in a relationship set, and entities in another set, entity set can participate more than once in a relationship set, then we say that cardinality as a many to one relationship. Then how do we mention it? Many in the sense n, and its ratio will going to be defined as n is to 1. So here also you can see the example or representation. We have an entity, that is many instances of this entity will going to have a relationship with only one instance of another entity. Then we can say this as a many to one. See here this A1 and A2 both will going to have a relationship with this B1, many to 1, and this A3 is also going to be participation of this relationship with B1, and if you take this A4, this is also going to have a participation with B3, and the same way you can also take the A3 with B3 here, so that many to one relationship exists here. So that here multiple surgeries will going to be done by a single surgeon. There could be a possibility, right? So many to one. So many or multiple surgeries will going to be done by single surgeon. This specifies the relationship. Then it specifies the cardinality ratio n is to 1. Fine. At last what we have? Many to many. So whenever more than two instances of one entity is participating in a relationship with more than one instance of another entity, then we call that as a many to many instance, and we are going to represent with the help of this m is to n. Many to many. Then how it will going to be defined here? N is to n. So this is also an entity and it is going to have a relationship with another multiple instance of another entity. Then we can say this as a many to many relationship. You can see here. So this is also what? Many to many. A1 is having a participation with B1 as well as B2 as well as B3, and is the A2 B1 and B3, A3 B1 as well as B2 B3. This is what? Multiple instance of one entity set having a participation with multiple instance of another entity set. This is what? Example for many to many. And here employees works on multiple projects. Multiple employees works in multiple projects here. So that's what it become many to many. So these are the different types which we have with respect to the cardinality ratio. What it is specifying? It is limiting the boundaries, or it is limiting the number of participation in a relationship. Now we got to know regarding this cardinality ratio. Next we'll see about the participation. So participation constraint and also existence dependencies. Then what do you mean by participation here? How do we have a restriction for the participation? We'll see here. The participation constraints specify whether the existence of an entity depends on its being related to another entity via relationship type. So what it is representing, it is going to this participation constraint will going to specify whether the existence of an entity depending on any other existence of another entity. Then that specifies the participation. What is the relationship between one entity existence to another existence of another entity? Then we can say that as a participation. This specifies the minimum number of relationship instances that each entity can participate in. If I have a 5 entity here, what is the minimum number of entities that will going to participate in the relationship with another instances of another entity? That will going to specify the participation constraint. For example, if you are conducting any of the event, minimum 10 numbers of students should participate from the class. That is what minimum constraint that we are having. So if it is exceeding, then we are going to change the constraint here. So that will going to specify the minimum number of relationship instance that each entity can participate in. And also we call this participation constraint as a minimum cardinality constraint. That means the minimum number of instance participation in a relationship is also considered as what this minimum cardinality constraint. Then what are the different types of participation constraint we have? One is total participation and another one is partial participation. As the name indicate, if it is a total participation and each entity is involved in the relationship, all the entity instances are also included or that all involved in the relationship, then we call this as a total participation. In the ER diagram, we are going to represent it by double lines. So here in the previous example, you might have seen that this is what an entity, this specifies the relationship and this is another entity. So whenever we have this double lines that specifies the total participation. Then what about this partial participation? Not all the entities are involved in the relationship. If I have a 5 entity, all the 5 entities may or may not participate in a relationship. If all are participating, total. If none of the things are participating or some of the entities are not participating, then we say that as a partial participation. So here in the partial participation, not all the entities involved in the relationship. Then how do we represent it? With the help of this single line. So here you can see the example in ER diagram, total participation, and also we call this total participation as a existence dependencies as well, will be displayed as a double line connecting to the participating entity type to the relationship, and partial will going to be represented by a single line. We'll see the example here. See, this will going to be shows the relationship between the student as well as the course. How many students are enrolling for a particular course? See, we have a what cardinality ratio? Many to many. So, n number of students are participating or enrolled for any number of courses. So, here we have a double line that indicates what? All the students are enrolled for certain courses. Okay, that is what the cardinality ratio as well as the participation constraint. Then how do we define it? You see here we have a student entity and also we have a relationship entity, that is what enrolled for. Here we have a course entity. See, student 1 is having a relationship, or it is going to be what stored for course 2, opted or enrolled for course 2, and S2 will going to be enrolled for course 1, S3 will going to be enrolled for course 2, S4 is enrolled for that course 2. Okay, so all the 4 instances are participating, but if you consider the course, none of the student had taken this course 3. Correct? That is what every student in a student entity said participating in a relationship, but there exists a course 3 or C3 which is not taking a part in the relationship. Then we are going to specify with this single line that specifies the partial participation, but all the students are enrolling for different course, not for a particular course. Then this becomes total participation. This is what? Fine. Next, we'll see the next topic. That's all regarding what? Weak entity type and identifying a relationship types. Already you know that with the help of key attribute, we are going to specify the uniqueness of a entity. But if we don't have that key attribute, in order to identify the entity uniquely, then we can say that as a weak entity set here. So that there exists some entity type for which key attribute can't be defined. So with the help of dependencies or with the help of another attribute or key attribute, this will going to be identified. Then we call that as a weak entity. Then we call that as a weak entity type. If you say the example of company, that may store the information of a dependence. For example, parents, children, spouse. So they are building a relationship. So what is the relationship of this person? That means whether he is going to have a spouse, whether they have children or parents. By them, they are representing these people of an employee. But the dependents don't have existence without the employee. So that spouse or children or parent won't be recognized without this employee. So employee is working as a strong entity. So all these parents, children and the spouse will going to be act as a weak entity. So that weak entity will going to be identified only there is existence of that employee. Okay, so only children can be identified only when we have a parent. So that parents is a strong entity and that children is a weak entity. Children can be identified with their parent. So the dependent will be weak entity type and employee will be the identifying entity type for dependent. So here identifying entity types specifies the strong entity that has its key attribute. With the help of this, we are identifying a weak entity. Here you can see that how do we represent this weak entity? With the help of this double rectangle. So usually we are going to use a single rectangle in order to specify the relationship, but if we have a double rectangle that specifies, that is having a weak entity relationship type here. The participation of weak entity type is always total. So always it is total participation. Why? Because it is getting its identification with the help of another entity, so that it needs to be, that participation has to be total. That is what we are representing, two parallel lines here. The relationship between the weak entity type and its identifying strong entity type is called identifying relationship. Then what do you mean by identifying relationship? How do we find the relationship between the weak entity and strong entity? When there is existence of the relationship, then we call that as a identifying relationship, and that is also going to be represented by this double diamond. So here you can see that here we have a entity, this is strong entity, this is what? Weak entity. So weak entity is going to be represented by this double rectangle, correct? And here we have a identifying relationship with double diamond, or it is going to be represented as what? Double rhombus shape. So here employee is a strong entity. Employee has dependents, that can be parents, children or spouse, like that. So this is total participation, this is identifying relationship, this is strong entity, this is weak entity. It's all regarding what? Weak entity type and how we are going to identify a relationship between the weak as well as the strong entity. Next we'll see about this ER diagram. So till now we have used many of the symbols. How do I get to know? Am I supposed to use a rectangle for an entity? How do we use a double diamond or a double rhombus for the identifying relationship? In order to get to know that, first you must know what is ER diagram or entity relationship diagram, and why we are supposed to use that, and what are the different symbols or shapes we have in that ER diagram. You can see here, it's a visual representation of a data that describes how the data is related to each other using ERD symbol. Entity relationship diagram symbols as well as the notation. By making use of this ERD symbols and notation, we are having a visual representation of a data and the relationship among the different data here. So whatever could be the object, so that can be what? Table, entities, attributes, or relationship set, attribute, relationship set, everything will going to be specified with this ER diagram. And also it is important in order to represent the schemas rather than the instance. So here what college infrastructure is moreover concerned than the number of students, isn't it? So if I take this sentence, I just need to bother about the structure of a schema. That means how many tables should be there, what are the constraints, and how it needs to be restricted. That is important than what kind of values I am going to store or what is the value. First, we have to give more privilege for schema rather than instances, so that it will going to be more useful in the database design, because a database schema changes rarely. As I told, students may come and go from college every year, but the infrastructure of a colleges changes rarely. So that is what? Schema changes rarely, and in order to define that schema, we are using this ER diagram. That is what the significance. So we are not showing or we are not representing the instance. So I am going to represent a student as student ID, name. So for this year, certain student name ID will be something. For next year, that values will going to be different. That means what? The student remains same, that schema remains same, but the instance of that student will going to be changed. In order to represent the schema, we have this ER diagram. So that schema is obviously easier to display because it's much smaller than the instances. Here you can see the symbol as well as its meaning. So here if we have a rectangle that specifies an entity. If it is a weak entity, then it is double rectangle, weak entity. This specifies the relationship, and if it is a double rhombus or a double diamond, then that specifies identifying relationship. Next what we have here, ellipse or what it represents the oval. It specifies the attribute. If it is a key attribute, if I wanted to find the strong relationship, then we have a ellipse that will going to be the name of an attribute will going to be underlined by this underline. Then we call that as a key attribute. Next we have a multiple values. So for example, phone number or email ID. In order to represent this value, we have a double oval. So when you look into this, you can easily say that if one ellipse is connecting to another ellipse, then we say that as a composite attribute. Example, name. So name, first name, middle name and last name. If I take the address, so that is also going to be specified, street, city and state, like that. Fine. We'll see the further ER diagram symbols here. So here you can see that we have a partial participation. If it is a double line, that specifies the total participation of this entity 2 in a relationship. Next what we have, 1:n, that specifies the cardinality ratio, correct? Then what we have, minimum maximum, that is a structural constraint. It can be minimum or maximum on the participation of E in the relationship R. So these are the different symbols, shapes we have in a ER diagram. I hope you all understood. We'll see the next one, that is regarding design aspects. Whenever we are having this ER diagram, so this ER diagram moreover is what consists of, or it will going to be mainly meant for what? Schema, not for the instance or a snapshot. So that somehow it is difficult to decide whether a particular concept should be modeled as an attribute, as an entity type or as a relationship types. Whenever we are doing this ER diagram, at the time it is difficult to understand or difficult to segregate whether it needs to be attribute or an entity or as a relationship type. And also the schema design should be considered as an iterative refinement process. At a one shot or at the beginning only we can't decide or we can't have a complete ER diagram. This needs to be what? Iterative refinement process. That schema design has to be iterative. So whenever we are doing the updation or whenever we are making a changes, everything should reflect on the schema design process. That is what it should be, iterative. It should not be static in nature. So that when an initial design is created and then iteratively refined until the most suitable design is reached. Until we are going to reach the satisfiable design for the schema, until that we have to do the refinement. Then how we are supposed to give a name for that? We'll see the naming conventions used in the ER diagram. So whenever we are having this naming convention, at the time we have to give a appropriate name for the object which and all we are using in a database. So that we have to choose a name that should convey as much as possible. If I am representing a data with respect to the student, I should not take a name of employee. That is not necessary there. So that whenever we are having a name convention, at that time that has to convey as much as possible, then the meaning attached to the different constructs in the schema. And then here you need to understand one thing, what are the name or whether it is capital, small letter, uppercase, lowercase, what we have to use. You can see here, that means that entity type and relationship type names are in uppercase letter. Whenever you are using entity type and relationship type, at the time we have to use uppercase letter. And whenever we having this attributes, that names has to be in the name, attribute name, the initial letter should be capitalized. Then we have to use lowercase for the role names. So this is what you need to remember. So these are the things which you need to remember whenever you are naming the conventions or object of this ER diagram. I hope you all understood my today's session. Let me meet you in the next session with a unit 2, that is relational data model. Let me meet you there. Until that, keep learning, keep on growing. Thank you.